Hello, Midnight Coders. Come on in, come on in. Grab a coffee, grab a coffee. You've probably seen Spring Security look a little bit like this, and that's usually where the conversation ends. Admins can do this, users can do that. Throw a role admin onto the users, and we're done. Today, we are going to go a bit deeper because Spring Security isn't really about roles. Roles are just a nice piece of information that Spring Security can use when making authorization decisions. However, once you understand, once you've understood that, then you can start asking much more interesting questions. Can a user modify this particular data? Can an employee access this particular order? Can a customer access their own account but not someone else's? Can I make an authorization decision based on information attached at the authenticated user? And perhaps most importantly, how does Spring Security even know who is calling my method? That's what we're going to be exploring today. And before we touch on any annotations, we need to break down and separate the two concepts that developers mix a lot: authentication and authorization. Authentication answers, who are you? Whereas authorization answers, what are you allowed to do? So if I log into our cafe with my credentials and Spring Security authenticates me, it establishes an identity, but it doesn't automatically mean that I can delete products, view queries from other people, change prices, or manage employees. Those are authorization decisions, and Spring Security keeps information about the authenticated identity in something that's called the security context. And that context contains an authentication. And authentication contains, among other things, the principal, the credentials, and the authorities. So, the important one for us today is the principal. So, Spring Security's documentation describes the principal as the identity being authenticated with username and password authentication. That can initially be a username, but after authentication, it can commonly be a richer user details object. Now, when we talk about the current user, we are really talking about information that Spring Security has attached to the current authentication. So let's start out with something simple. Let's say that our cafe has an administrative um, operation, something like this. Now, it's pretty straightforward. If the authenticated user has a role of admin, then Spring allows the method to execute. If they don't, Spring doesn't execute it. That's the important thing. We're not putting user.isAdmin into our code. Instead, the method itself, we are declaring the authorization requirement at the method boundary. And to do this, Spring Security will need to be enabled. So we would start off with our security config, and we may slap in an annotation at enable method security. Method security isn't automatically active by just default because Spring Security is on the class path. um, at enable method security enables annotations such as pre-authorize and post-authorize. But roles aren't enough. Here's where things get interesting. So imagine that our cafe has a few different authorities: product read, product create, product update, product delete, order read, order update, so forth. And now instead of asking pre-authorize has role of admin, we can simply say pre-authorize has authority, and we provide the authority, product delete. And that's a completely different way of thinking about authorization. A role is broad. It's a broad classification, and an authority can represent a specific capability. So Spring Security doesn't actually care whether your authority represents a role, a permission, or some other scope. Okay? It's ultimately evaluating the authorities that are associated with the authentication. So suddenly we now have something that looks like this and something that looks like this. Now we are expressing what someone can do rather than simply what group they belong to. So, what if our ownership matters? So, here's where roles completely fall apart. Um, Suppose we had an order, something like this, public order, get order with an ID. Now, a customer should be able to retrieve their own order, but they shouldn't be able to retrieve mine. So now both of us may be a role customer, so this doesn't solve the problem at pre-authorized has role customer because both customers technically pass this check. And the real authentication rule is this person requesting the order must own the order. And now we need something a little bit more interesting, and we need to know who is making the request. So, meet your authentication and principal. Inside of a method security expression, Spring Security gives us access to authentication and principal. Authentication is the complete authentication object, whereas the principal represents the authenticated identity contained inside of it. So we can do things like this, for example, where we can check to see if the authenticated name is equal to that of the username that we're trying to find. Uh, and now our authorization rule is no longer, are you an administrator? It's now, does the username that you're asking for match the identity of the authenticated user? And that's fundamentally more powerful, um, a much more powerful model. But like, what actually is inside of the principal? So this is an important point. A lot of developers see principal and think that it's some magical Spring Security user object. And it isn't. It isn't. It's actually a type. Um, the type of it actually depends on how authentication was configured. So Spring Security's authentication hashtag get principal can contain a richer object such as user details. And for example, our application might have something like this. And after authentication, Spring Security um, can have an authentication whose principal is for the object. So now conceptually, we have something that looks a little bit like this over here. And that's why principal matters. It gives your application a way to understand who is currently authenticated. So now let's put this into our cafe. Imagine our database contains something like this for our users, and they have their roles. And then we have one for orders. Now, Alice logs in, and Spring Security authenticates Alice, and her authentication represents Alice. Now, so if Alice asks for order 101, our service might look a little bit like this. Does the order.user ID equal to the principal.id? And that's how we would check to see if the authenticated user gets access to this order. Now we're doing something much more interesting, okay? So now we're comparing the resource to the user ID against the authenticated user and the principal ID. So this is a resource ownership authorization. And notice what we didn't do. Okay? We didn't create a whole bunch of order number this, order number that, and try to stick everybody into their own particular roles. That would be ridiculous. Instead, we are evaluating the relationship between the authenticated user and the resource. So, method parameters are a part of Spring Security's decision, and that is another major feature of method security. Spring Security can expose method parameters to the authorization expression, such as pre-authorized, user hashtag username double equals authentication.name. And so now the hashtag user refers to the method parameter. Sorry. And now we can compare that to the authenticated user. And now the method itself becomes part of the authorization decision. So we're effectively saying before this method executes, compare its input with the authenticated identity, and let's that is a significantly more expressive than just a URL level security alone. And let's make this a little bit more realistic. So suppose we have something that looks like this, and we could secure these independently by doing something like this. Now, already our authorization model is becoming more expressive, but we can go a step further. Imagine multiple conditions. So imagine an employee who can update an order only if they have the appropriate permission and they're working in the cafe that owns the order. So we can do a pre-authorize, and we can throw in a little string template here to say has authority, and the order number, the order from the cafe, matches that of the principal's cafe, saying that this user belongs to this cafe. And now our authorization decision is a little bit more like authorize or authority, authenticated user, method parameter, resource, and that's the real power of method level authorization. But eventually you're going to be writing something ugly that looks a little bit like this. Stop. Don't turn your annotations into a programming language of its own. Okay? Spring Security allows you to delegate authorization to its own Spring bean, so you can do something that looks like this. And then um, you can make something that looks like this. Now, the annotation says authorization is required, and a Java class says, well, here's the authorization means, or here's what the authorization means. And it's a much cleaner separation. So Spring Security explicitly supports calling Spring beans from within the method security expressions, which is particularly useful when the authorization logic becomes complex enough to deserve normal Java code and interpret independent tests. So now, earlier I had also mentioned post-authorize. So far, we've seen everything happen before the method was run. But what if we want the method to run and then return whether or not we can actually use what was returned? That allows Spring authorization, or sorry, that allows authorization decisions to consider the method's return value. So, something like this, the method runs, the object comes back, and then Spring Security evaluates whether or not the object is allowed to be returned. And this can be useful for ownership checks and for protecting against situations where somebody might otherwise retrieve another user's resource. And Spring specifically documents post authorize for this kind of object level authorization. But there's an important warning. Do not use post authorize as a security check around a method that performs a database write. This is because the time that it takes to do the authorization check, that write already may have happened. So for writes, we generally want to use authorization before the operation happens. So where does the principle actually come from? Well, now let's pull back the camera for a second. And when a request enters our application, Spring Security's authentication machinery establishes an authorization. The authorization is stored in the security context. And by default, security context holder makes the context available for the current thread. So our application doesn't need to pass the user object through every single method. Spring Security already knows the authenticated user is who the authenticated user is, because when we access authentication directly through security context get context get authentication, and from here we can do authentication get principal or authentication get authorities. And this is the machinery underneath it all. Uh, this is kind of an important mental model to keep track of. A request comes in, the HTTP request comes in, Spring Security then authenticates it, grabs the principal and the authorities, and Security context is then on top of your application. And then we reach a method that has pre-authorize on it, and Spring can evaluate the expression before the method is actually allowed to execute. If authentication passes, we just continue on the method. If it fails, we stop and access is denied. And this is when this happens, a normal HTTP request, then Spring Security can translate that into a direct 403 forbidden. So this is the part that I want you to take away. If you only know pre-authorized has role admin, then you know one feature of Spring Security. If you understand has role, has authorities, authentication, principal, method parameters, custom authentication, authorization logic, post authorize it, then you've started to understand method level authorization. And that's a completely different level of understanding, because now you can you can model rules like administrators can manage everything, employees with product update can modify products, customers can access their own orders, and managers can modify orders belonging to within their cafe, and a user can only access resources associated with their identity. So those aren't merely roles, they are authentication policies. And Spring Security gives you a machinery, or gives us the machinery to expose these policies directly to the boundary of our application logic. So in closing, this is where Spring Security gets really interesting. Authentication tells us who you are. Authorization determines what you're allowed to do. And method level security gives us a remarkably powerful tool. Uh, to enforce these distinctions. Now that you've just now that you're not just securing endpoints, we are securing the actual operations that make up our application. And that is a much better way to think about Spring Security. So as always, guys, keep your curiosity open, your skills sharp, and that coffee cup full. And then I'll catch you in the next one.